Alright, this is video 2 of the fall geometry review. I didn't get through quite as many problems in the first video as I thought, so this will pick up with problem number 9, and I don't know how many problems I'll get through. I'll label it in the title though when I get finished. So this shape right here, we were talking about classify the figure below based on number of sides. It has 1, 2, 3, 4, 5 sides. All the shapes you should know to be a functioning adult in our society are the triangle. It has 3 sides. The quadrilateral, it has 4. This one right here is a pentagon. It has 5. There's also the hexagon. It has 6. And the octagon, it has 8. Now, there's lots more for every number. There's a word prefix for 7, 9, 10, 11, 12, 13, 14. Eventually, we just start saying they are n-gons. It's nice to know the 7, the 9, the 10, and all that, 11 and 12. But these are the ones you really know. You really need to know. At your job someday, somebody might say, you know, go get the box, the one with the purple octagon on the side. Well, you better know what an octagon is. So this one leads right into this one. Which one has 8 sides? An octagon. So there we're getting 2 birds with 1 stone there. Find the circumference of the circle. The circumference is the distance around the outside. Whoa, except around the outside, not inside. There is a formula for circumference. C equals 2 pi r or pi d. Now when you get these problems, the one on the test might not be exactly like this. You have to remember, when you're looking at a circle, the distance all the way across is d, and this distance just from here to here is r. D equals 2 times r, and that's why they're kind of interchangeable here. If you look, 2r and d. Okay, so which one is this right here? Well, that goes all the way across. That's 16, so that's d. That can go right here. Pi times 16, which we usually write as 16 pi. Now, on the multiple choice test, that could be the answer, or they may have it multiplied out, 3.14 times 16, 50.24. And normally you want the label, meters right there. You shouldn't have to worry about that on the multiple choice though. That is the circumference of that circle. Solve for x. Where's my problem? Oh, okay, there it is. Solve for x. Well, now here's what you need to realize. Anytime you have a straight line like this, and another angle coming out of the middle, these 2 angles right here, this distance will always be 180 degrees. Okay, these are called a linear pair. All linear pairs are supplementary. So looking at these 2 things right here, I'm going to say angle KPL plus angle LPJ equals 180 degrees. Well, KPL is 2x plus 24, and LPJ is 4x plus 36. Together they need to total to 180. All right, we got to combine some like terms. We'll have a little algebra thing to solve here. 2x and 4x are like terms. They both have a variable. That'll be 6x. And then 24 and 36 are also like terms. They're both constant numbers. 36 plus 24 is 60. And now we can solve this real quick. Minus 60 from both sides. That cancels. 6x equals 120. We'll divide by 6 on both sides. Those 6's will cancel. And x equals 20. Now remember what I said in video 1. You get these x things. We want to go back and make sure it's not asking for angle KPL or angle LPJ. And if I look up here, solve for x, well, that's what I did. So Happy Math Guy is happy we've got what we need. Angle 1 and 2 form a linear pair. Hey, this sounds like that same last problem. So whatever they're doing, there's 1 and there's 2, they add together to make 180. So angle 1 plus angle 2 equals 180. Let's see. 2 is 81. So angle 1 plus 81 equals 180. Minus 81, minus 81. Angle 1 equals 99. And let's see, what's the measure of angle 1? Well, there it is, 99 degrees. All right, use the figure below. Here's this three-dimensional shape. It looks like a cube. Point F is meant to be in the back. When you see those dotted lines, that means it's in the back, the part we're not supposed to be able to see. And we want a segment that goes through point A and is parallel to segment DH. Well, I like to draw in DH when this is going on. There's DH right there. And let's see, we need to go through point A. Here's point A. Well, that really only leaves us 3 choices for segments that go through point A. We want to be parallel to DH. Now, parallel means that it will never ever touch DH, the segment that we're going to choose, but it also means it has to be in the same plane. So between the fact that DH is on the front corner, front edge of this cube, and that A is on this other edge, really the only one we could pick and have it be parallel and on the same plane, since we have to go through A, is this one right here. So I'm going to say, I guess it's segment AE. Oops. I'm going to say segment AE is the only one that's going to be parallel to DH and on the same plane. Now let's see. Let's do the next one. Name a segment that goes through point A and is skew to DH. All right, well, it's got to go through A again, so I'm either picking this one, or this one. And which one is skew? Well, one moment. Sorry about that. Apparently supper is ready. Spaghetti pie. Spaghetti pie. So I was on 14B here, and name a segment that goes through point A and is skew to segment DH. Well, let's talk about the difference between parallel and skew. If you've got these two items here, these are parallel. They look like they could be in the same plane. They're never going to touch. They go on and on forever. To be skew, you need to be in a position where they will never touch, but they will go on and on forever, and they cannot be. There's not one plane that will contain both of these right now. So for A, I wanted one like this, and that's why I took the 2 off the front of the cube. Now I need to take this 1 off the top corner. They will go on forever and ever. They would never touch. It cannot be coplanar. Ones that are skew are not coplanar. So I'm going to take this one right here. Well, again, I guess it's not a line. It says a segment. So it contains A, and it is skew. It's never going to touch that red one. So this is AB. Now the next one also has to contain A, and it says through point A and perpendicular to DH. So it needs to cross it at 90 degrees. I kind of wish that was worded differently, because this one right here, AD, is the only good answer here. We really don't have any evidence that that's perpendicular. I guess we're going to make an assumption, which is really something we should never do. I kind of wish this said appears to be perpendicular, because we don't have any 90 degrees here. But really, the only one it could possibly be is this one right here. We're going to have to go on faith that they've made a proper cube. All right. In figure 2, in the figure, angle 2, this angle right here, and angle 8, this angle down here, are which one? And I listed all the relationships down here. Alternate interior, alternate exterior, corresponding, same side interior. No, which ones are equal, which ones are supplementary. I usually find it beneficial to draw a more extreme, there's my lines, there's my transversal. I like to draw a more extreme version like that. Now we can talk about if these lines are parallel right here, all of these more acute ones that look like they're equal, Well, surprise, they are. All these more obtuse ones that look like they're equal, surprise, they are equal as well. Also, if you pick one acute and one obtuse, it will add to 180. So if the lines are parallel, all the ones that look equal in the sketch are. All the ones that look like they should add to 180, well, they do. Now you need to know what these various ones mean. Like this. That's alternate interior. Next one. That's alternate exterior. Next one, like this. Corresponding. This one on the top left goes with this one on the top left. This one on the top right is corresponding to this one on the top right. This one in the bottom left is corresponding to this one in the bottom left. This one in the bottom right corresponds to this one in the bottom right. Last one is same side interior. That's right here. Basically, there's a few keywords, and if you can keep them straight. This is the interior. This part out here is an exterior. This part out here is an exterior. This thing right here going down the middle, that's the transversal. If the items are on the same side, you can call them same side. If they're on opposite sides of the transversal, we call them alternate. So if you can get those words straight, then you can get through this part pretty easy. All right, angle 4 and angle 6. Let's see, that's this one right here. Oops, I don't know why I did that. Angle 4 is this angle right in here, and angle 6 is right in here. Well, let's take a look and break this down. They're both in the interior. So they're interior, and they're on opposite sides of line N, which is the transversal. It's the one that crosses the other two. So they are alternate interior. And if L and M are parallel, which we don't have any indicators, but let's say they are parallel right here and right here, then 4 and 6 will be congruent. We just don't know that right now. All right, next up here, use a figure to find the measure of angle 5. Well, there's angle 5 right there, and it looks to me like it's a linear pair with that 125. From here to here should be 180. So 5 plus 125 equals 180. Oops, that's angle 5, not 5. That wouldn't make any sense. That cancels. Angle 5 equals 55 degrees. And something felt a little weird there. I'm going to check it out here. 3, 8, 180. Okay, it works. So angle 5 is 55 because they're a linear pair. Now on to number 18. Which theorem guarantees L and M are parallel? Well, remember what I said. This is the interior and they're on opposite sides, so they are alternate. So I'm not sure the exact wording off the top of my head, but in your multiple choice, you need to look for the alternate interior. And since we're going backwards, we're saying if the angles are equal, what would make the lines parallel, it's going to be the converse. Because we have the one that says, hey, if the lines are parallel, then these are equal. And then the converse says, hey, if these angles are equal, then they're parallel. And that's the converse one. That's the one we want. I'm going to break there. I won't have time for the next one, and I'll be back to you in video 3, starting with number 19.